What does the factory of the future look like? If you're imagining a place where cars are built without consuming fossil fuels, where intense industrial heat is generated without carbon emissions, and where energy arrives not by truck, but through pipelines carrying the most abundant element in the universe, then your future vision is taking shape right now at BMW's Leipzig plant in Germany. In a groundbreaking move that signals a major shift in industrial strategy, BMW is transforming this production facility into the world's first car manufacturing plant, powered directly by hydrogen pipeline. This isn't just an incremental improvement, it's a complete reimagining of how factories can operate in a carbon-constrained world. When we talk about the transition to green energy, we often focus on the vehicles themselves. But what about the factories that build them? BMW is addressing this exact question with a project that could set the standard for automotive manufacturing for decades to come. The significance of this development cannot be overstated. On October 1st, BMW revealed that it had signed contracts to connect the Leipzig facility directly to Germany's future hydrogen core network, a move that positions the plant at the forefront of industrial decarbonization. This pipeline connection represents more than just infrastructure. It's the centerpiece of a comprehensive strategy to make manufacturing compatible with climate goals while maintaining and even enhancing operational efficiency. The Leipzig facility isn't new to innovation. It's the birthplace of the revolutionary BMW i3, the company's first mass-produced electric vehicle, and has long served as a testbed for sustainable manufacturing technologies. Now it's preparing to write a new chapter in industrial history, one that could influence how factories across multiple sectors approach their energy needs in the coming years. The technical details reveal a carefully planned project with multiple stakeholders working in concert. BMW has partnered with two specialized energy companies to bring this vision to life. Mitnetz Gas will construct the approximately 2-kilometer, 1.2-mile connection line that will link the plant to the main hydrogen network, including a gas pressure regulation and measurement facility, while Ontras Gas Transport will handle the technical network connection to ensure seamless integration with Germany's broader hydrogen infrastructure. This division of labor leverages the specific expertise of each partner, creating a project team capable of delivering a robust, reliable hydrogen supply system. The timeline for this project is both ambitious and concrete. After the necessary construction and testing phases, hydrogen is expected to start flowing into the plant by mid-2027, providing a clear target date for this energy transition. But the Leipzig connection is just one piece of a much larger national infrastructure project. Germany is building a hydrogen core network that will eventually span approximately 9,000 kilometers, 5,592 miles, across the country, with construction happening in stages and full operation targeted for 2032. This network is designed not as an isolated system but as a national backbone that will link regional hydrogen suppliers and users while also connecting Germany to neighboring countries, creating a trans-European hydrogen economy. By being an early participant in this network, BMW ensures greater stability in supply and gains valuable experience in hydrogen applications at scale. To truly appreciate the significance of this pipeline project, we need to understand how hydrogen currently arrives at the Leipzig plant and why the transition to pipeline delivery represents such a dramatic improvement. Presently, hydrogen is delivered to the facility by truck in pressurized cylinders, a system that creates multiple challenges. Each delivery requires handling, storage, and constant coordination to ensure supply doesn't run out. The logistical complexity is considerable, and the transportation itself generates carbon emissions that undermine the environmental benefits of using green hydrogen. There are also inherent safety considerations in frequently handling high-pressure containers and limitations on how much hydrogen can be practically stored on-site. The transition to pipeline delivery will revolutionize this system. Imagine the difference between receiving water via occasional truck deliveries versus having it continuously available through a tap. That's the kind of transformation BMW is implementing. Petra Peterhensel, director of BMW Group Plant Leipzig, perfectly captured the significance of this shift when she stated, "With supplies coming in via the pipeline, we will be able to use hydrogen in completely new ways, especially for our most energy-intensive processes, such as our curing ovens in the paint shop." This continuous, reliable supply won't just replace the current truck-based system. It will enable applications that simply weren't practical or possible with intermittent deliveries. The pipeline will provide a steady, high-pressure stream of hydrogen that can be precisely regulated for different industrial processes, removing the bottlenecks that previously limited hydrogen use at scale within the facility. While the pipeline project represents a quantum leap in hydrogen infrastructure, it's important to recognize that BMW's journey with hydrogen at Leipzig didn't begin with this announcement. The plant has been steadily building toward this moment for over a decade, establishing itself as a living laboratory for hydrogen applications in automotive manufacturing. This extensive experience has provided the knowledge foundation necessary to confidently make the transition to pipeline supply. The plant's hydrogen story began back in 2013, when it introduced hydrogen fuel cell-powered forklifts and tugger trains for its intralogistics operations. What started as a pilot project has grown into Europe's largest fleet of its kind, with 230 vehicles now operating within the facility, supported by 9 hydrogen refueling stations located throughout the plant. This substantial material handling operation has given BMW invaluable real-world experience in hydrogen safety, refueling procedures, and maintenance protocols. Then, in October 2022, the plant achieved another world first by introducing fuel-flexible burners in its paint shop. These innovative systems, developed in collaboration with the Bremen-based company Saka, and with support from the Fraunhofer Institute IFF, can operate on natural gas, hydrogen, or any mixture of the two, switching between fuels while in operation. Today, the paint shop operates 11 such bivalent burners, primarily used in energy-intensive processes like curing ovens. This existing hydrogen-capable infrastructure means that when the pipeline becomes operational in 2027, the plant will be ready to immediately leverage the improved supply. The significance of BMW's pipeline project extends far beyond the boundaries of the Leipzig plant, offering a compelling vision for the future of industrial manufacturing while delivering concrete environmental and economic benefits. From an ecological perspective, the transition from truck-delivered hydrogen to pipeline supply creates a virtuous cycle of emissions reduction. First, it eliminates the carbon emissions associated with transporting hydrogen by road. Second, it enables the replacement of natural gas with green hydrogen in high-heat applications, potentially reducing CO2 emissions from the plant's most energy-intensive processes. One analysis suggests that swapping trucks for pipes could cut logistics-related CO2 and NOx emissions by up to 50% per kilogram of hydrogen delivered, a significant improvement when multiplied across the hundreds of tons the plant will consume. Annually, the economic case is equally compelling. While the initial infrastructure investment is substantial, the operational savings are projected to be significant. By eliminating the cost-intensive truck deliveries, BMW expects to save millions of euros over the next decade, with early data pointing to a 20–30% reduction in hydrogen procurement costs, thanks to direct pipeline delivery and reduced handling fees. These savings can then be reinvested into further decarbonization efforts, creating a positive feedback loop that accelerates the plant's journey toward climate neutrality. Perhaps most importantly, the Leipzig project serves as a scalable blueprint for other manufacturing sectors. Industries with similar high-temperature process needs, such as steel, cement, and chemicals, are closely watching BMW's initiative as a potential model for their own transitions. The project demonstrates that with the right infrastructure and technology, even the most energy-intensive industrial processes can be decarbonized. As Germany and other countries build out their national hydrogen networks, the lessons learned at Leipzig will undoubtedly influence how factories across multiple sectors approach their energy transitions. BMW's hydrogen pipeline project at its Leipzig plant represents exactly the kind of ambitious, infrastructure-level thinking necessary to decarbonize industrial manufacturing. By moving beyond symbolic gestures and making substantial investments in core energy systems, BMW isn't just reducing the carbon footprint of a single factory, it's helping build the foundation for a post-fossil fuel industrial economy. The project cleverly builds upon more than a decade of practical experience with hydrogen applications, ensuring that when the pipeline becomes operational in 2027, the plant will be fully prepared to leverage this improved supply to its maximum potential.